Well, good morning and welcome everyone in this fifth webinar of the ECOSYSTEX Insights Series. On this lovely Friday morning in September, we will have some webinar procedures that I would like to ask you to follow today. So as you might have seen already, we are recording this webinar. So if you don't want to be heard or seen in the recording, then please turn off your camera and also please keep your microphone muted at all times. If you have any questions, then you are more than welcome to type it all the webinar in the chat, which we then will address at the end of the webinar when we have a dedicated Q&A moment. In that moment, if you would like to elaborate on your question, then you're also welcome to raise your hand and then we will invite you to speak. Today, we are going to have 4 speakers from 4 ECOSYSTEX member projects. As you can see here, at the beginning, I will give you a short introduction into what ECOSYSTEX is, in case you would be here with us in this series for the very first time. Then we are going to hear from RegioGreenTex, the R-LIGHTBIOCOM, the PROPLANET, and the myco-fibres projects. Then, as I already mentioned, we have a Q&A towards the end of the webinar, and we are going to go through all the questions that you have typed beforehand into the chat, and then the speakers will give you the answers, and then we are going to wrap up and aim to finish on time around 11:30. As mentioned before we kick off, let me give you a brief introduction into what ECOSYSTEX is. Well, ECOSYSTEX is the European Community of Practice for a Sustainable Textile Ecosystem. We have 24 member projects in this community, which are all European-funded projects focusing on textile circularity and sustainability. Well, the objectives of ECOSYSTEX are threefold. We have, first of all, as an aim to enhance inter-project collaboration, to really bring together all these projects, all the knowledge and the experts from all across Europe, all working on the same or similar topics related to textile circularity. We also aim to enhance engagement with policymakers and support them in their decision-making and policy-making by providing expert input. And finally, we would like to also reinforce the effect of all the work that's been done in these projects by organizing dissemination activities, such as today's webinar, where we are making sure that the interested public outside of the community can also be informed about what's going on in the technical work of these projects. As I mentioned, we have 24 member projects, which you can all see here represented with the logo on the screen. And the ones highlighted now, so myco-fibres, RegioGreenTex, PROPLANET, and R-LIGHTBIOCOM are the ones that we are going to hear about today. ECOSYSTEX is mostly an online community. As we are international, we have members and experts from all across Europe. On the day-to-day basis, we work together online in webinars and Teams, all the platforms that you also use in your everyday work. But for the first time in October, we get to meet together. We are organizing the first ECOSYSTEX conference titled From Your Research to Sustainable Textile Business. We are going to get together in Barcelona. And a couple of weeks ago, we opened registration for this conference to the wider public as well, up until the 25th of September, so next Monday when we are closing the registrations. So I would like to give you a little insight into what this conference is about in case you would be interested to join, and use this opportunity to really look a little bit in the behind the scenes of this community, which generally works in closed working groups on technical topics. Then this is your chance. The conference will be organized over 3 days. Well, actually 1.5 full days on the 19th and the 20th of October, with a lot of interactive sessions and more insights into what's going on in the member projects. But also on the previous day, so Wednesday, 18 October in the afternoon, we are starting with kind of an optional addition, a facility visit in the EuroCat High Performance Textile Manufacturing Lab, which is just outside Barcelona. This is a chance for anyone who wants to join already from the day before. And then Thursday morning, we are going to kick off the interactive sessions. one more insight about the interactive sessions. They are going to target different aspects of textile sustainability and circularity. They are all led and also planned around the topics of our ECOSYSTEX working group. So all the technical topics that we are dealing with throughout the year, and also linking to what each project is dealing with on their own. So here on the upper right corner, you can see the 6 project logos that are each going to lead one session during this day. 3 interactive sessions will take place in the morning parallelly, so everyone can choose one of those, and in the afternoon, another set of 3, where everyone can choose a second one to participate in. You can also see the last session here highlighted. The reason for that is that this session is going to be led by the RegioGreenTex project. And today, this is a project that we are going to hear about. Actually, it's going to be our very first presentation. So if it hasn't happened yet, then I asked my colleague Tilla to drop the link in the chat where you can see a little bit more information about this conference. You have the registration link. If you're interested, please consider to register today or latest by Monday, because that's the final deadline. And with that, without further ado, I'm bringing back the agenda to see the first presentation. I'm inviting Jennifer Palumbo from Eurotex, who's going to tell us a little bit about what RegioGreenTex is up to, how they are strengthening textile circularity in Europe's regions. So Jennifer, if you're there.
Yes, hello, good morning.
Hi, Jennifer. Then the floor is yours. Please take over.
Thank you very much. Will I share my screen?
Yes,
Or
please do.
Are you going to share it? Because I sent the presentation, but it's as you wish.
If you don't mind, I think it's better instead of saying next, and then we keep changing for you.
Yeah.
Thank
okay.
you.
I think you need to stop sharing first, because then I can share. Yeah.
Please go ahead. And while Jennifer is setting her screen up, I know that she will not be able to stay until the very end of the webinar. So exceptionally, we will take questions to her right after her presentation. So please feel free to type your questions into the chat directly as she starts the presentation.
Thank you. Sorry about that. So thank you for the introduction. As you already heard, I'm Jennifer Palumbo, and I'm a project director with Eurotex, and I'm going to tell you about RegioGreenTex, Regions for Green Textiles. So this is a project that has been developed in the framework of the European Green Deal to help the textile industry become more circular. And it involves the 4 main sectors of society. It's called the quadruple helix project, because it has to do with research, with policymakers, so government, with industry, and with, let's say, the public, so the public at large. So, of course, it's a very ambitious project, and establishing circularity in such a complex value chain as the textile industry has is a big challenge. And so we are in a new EU instrument called I3. So the 3 I's stand for interregional innovation investments. And so, yeah, as you can see, this is sort of an ambitious type of project as well, because it has to do with regions, which is a local level that allows sort of local connections, same language, so there are certain closeness between actors, but also a big enough dimension that you can actually have some policy and have some specificities. And in fact, the regions that we have involved in RegioGreenTex are all have a textile strategy in place in the Smart Specialization Strategy framework of the European Union. We are looking for innovation, so we're not just funding, networking or research. We're really looking to advance technologies in circularity in textile, and investments. Of course, the project, as see in the next slide, requires investment from the partners, since it's only 70% co-funded, and it's a 13 million euro project overall. So there is a significant investment from the 43 partners in the project. In addition, we are looking to create a spillover effect where additional investments will be launched during the project lifetime or after. So it's really the idea to sort of launch some initiatives and projects that will continue and move forward. I said we are dealing with regions, so the project involves 11 regions in 8 different countries. You can see them here. They span sort of north, south, east, west of the EU. They are some of the most important regions in the textile industry. Of course, we started with regions that have a strong presence of textile industry and a strong history of dealing with textile to begin working on the circularity. So as I said, it's a multi-stakeholder engagement. Industry, research, public, and government are the levels that we deal with in terms of objectives. From the point of view of the organization of the project, every region has a regional cluster type of organization where it's either a development agency or a technical cluster. So for the 11 regions, we have an organization that is dealing with helping companies and industry develop as a business model. We have then 26 SMEs, so companies, there are 2 to 4 per region, so they're distributed. And these are companies that have come to the project with a pilot in mind, so an actual innovation that they're trying to develop and that they're getting funding for. We have regional hubs, so that's a sort of a innovative concept that we are developing within the project. I'll tell you a bit more about that later. And in terms of policy makers, which is one of our groups of stakeholders, we have a kind of advisory group, which we call Mirror Group, which is formed by the 11 regional administrations in the regions that we are involved in. So we meet with those representatives twice a year to inform them and to get feedback from them so that they will be in the loop for the policy aspects and even the financing aspects, because regions have quite a strong operational input in their territories. So going forward, we have 5 objectives, a little bit more in detail. The first is to map the needs and the potentialities in these regions. So to really take a good look at what the industry needs, what we can do, what they can offer, and so get a better impression about the also what's missing and what's wrong. We also want to build an ecosystem online, considering the long value chain and the very international nature of textile. It's very important that the SMEs in particular, which are the backbone of European economy, find ways to connect to each other and to find these partnerships. And so we are implementing a platform, a digital tool, where the SMEs can contact each other, can have some kind of a description of their activity, of their project, and they can find other partners. And of course, as a project, as I said, we have regional clusters, we have many sort of mechanisms and partners in place to support these SMEs to develop their pilot projects and to develop innovations that will help with circularity in a range of ways. So we have some products, we have some processes, we have new recycling, new sort of partnerships that we aim to create, and this is the core element of the project. In terms of the 5 regional textile recycling hubs, we are aiming to create, so that has to do with the regions in a way that I'll explain. And of course, we want to have centers that are specialized in a strategic topic that is consistent, that avoids repetition, and that sort of builds on the experiences available within the hub. And last but not least, in terms of investments, the Commission's objective in funding this kind of project is to de-risk SME investments, so to help, again, the engines of the European economy make the difficult investments and sort of big changes that are required to become more circular in a way that's less risky and less cumbersome for the single company. So we hope to do that with them. In terms of value chain mapping, which was our first objectives. So we want to map the value chains in its region, both represented in the project and beyond, consider the connections between regions. We want to analyze the gaps and bottlenecks, and we want to give feedback to policymakers. So we have a regional level within the project, as I mentioned, very closely connected with the Mirror Group. We have the EU level, considering there are several EU-wide organizations that deal with EU policymakers. But of course, the national level is something that's very important, and we count on the regions to go speak to their national representatives. In terms of online ecosystem, which is again our second objective, we already have this platform online, regiogreentex.eu. You can check it out. There is a public interface, but the part that we are developing in the project is a digital tool that is, for the moment, only for project partners. And it's based on a shared taxonomy and nomenclature, which is of course, not that easy to put together. That's one of the objectives of the work, to create some kind of taxonomy that will work across sectors, across languages, to allow some kind of classification and nomenclature that will be useful for companies to find each other and define their projects. We have SME digital matchmaking, so the possibilities for SMEs to ask questions, to post requests, to look, for example, for a feedstock, for a technology, for a partner. We're going to have a tool that allows companies to measure level of circularity in their project or in their whole company. So that's something that's also being developed. There will be a questionnaire of some kind where the company inputs information and receives recommendations or something like that to help them become more circular. And of course, we want to build a sustainable service. So this platform is one of our 26 SME projects, as I'll say in the next slide. And so we want to make this into something that will continue and have a business model after the end of the project. So in terms of innovation, I mentioned 26 SME pilot projects. One of them is this platform. There's 6 areas of innovation, all having to do with recycling and circularity in textiles. So it's the eco-design, waste collection, sorting. That's a very important point, how to make this easier, more automated, more precise. Use of secondary raw materials, that's of course also a big deal. If we can, use things for longer and better, instead of sending everything to recycling, it's an easier way to prolong the lifetime of materials. But then there's chemical recycling, so in the sense, once, let's say, the textile has finished its cycle of life, then it can be recycled and go back to having a high value. There's a mechanical recycling, and there's the zero waste approaches, which again are quite an important element. The project offers advisory services for SMEs. So we have within the consortium experts that will advise SMEs in different aspects that have to do with marketing, legal. It can be how to bring their services to a market. It can be technical, it can be testing. So there's a range of services that the consortium offers. And we aim to help companies produce an exploitation and an investment plan. So really to help them get to the next level, thanks to their participation in the project. So the next dimension in the project is regional hubs. So 5 clusters, let's say regional or multi-regional, are developing what we call a regional recycling hub ecosystem. So from an area, which we'll see now which they are, but they're focused and experienced on a specific topic or area. We're developing a roadmap, a bundle of SME business cases, and we're preparing to have then a general hub investment strategy and a model of collaboration and ecosystem based on a strategic objective, so a specialization. And we want to produce a model or a blueprint that can then be used in other regions. So the idea is to really have an idea of a model of collaboration that can work, because Europe is made of many different regions, and Europe is very varied, and we don't have a central government, and we can't just sort of organize. But the idea from the European Union is to specialize strategically so that regions have an organized approach overall, and every need is covered in a way that makes sense for Europe as a whole. So it's quite an ambitious objective. There's, as you can imagine, many actors involved. We try to go in the direction of creating some synergies and ecosystems on the basis of some pilot projects. So here we have the 5 hubs that the projects put together. So you see the lowlands, that's historically they're connected, north of France, eastern Netherlands, Flanders. Italy has Piedmont and Tuscany, and then Auvergne, Rhône-Alpes, North Portugal, and Northeast Romania are the 3 that have one region in them. And then we have, of course, 3 regions that are not within a hub. So these regions will benefit from the hubs as they're being developed, and we'll be able to apply the model that the project puts together. And yeah, the objective of the hubs is to support SMEs and their upscaling objectives, to attract investments, because of course creating a structure will help institutional investments first of all, but hopefully also private, and create effective value chains that don't require hopefully the companies to go outside the European Union for everything, like it is a bit the case now. So I do have a little bit more to say about the general. I'm going to jump over these because I see my time is up, but maybe we can go back if there's questions, or you can have the slides to see later. What we expect in terms of results of the project, we expect to have an improved knowledge on the sector's needs and really give feedback to the policymakers in this moment where the legislation is changing and really moving towards the circular model. We expect to have a lively ecosystem of stakeholders that interact online and find each other through the platform in an effective way. We expect to see some advances, technically, some processes, so that recycling will have some more tools, and that the textile industry has additional ways to move towards circularity. We expect to have 5 regional hubs, so with each a specific focus, plus a blueprint for the other regions to organize as well. And we expect to have advice and plans to support SME investment to create circular economy for the EU and beyond. So thank you very much. And I think if there's questions, I'm happy to.
Thank you so much, Jennifer. Indeed, there is one, well, actually 2 questions from the same person in the chat for you. So the first is, you have talked about a tool to measure the level of circularity. Can we find somewhere more information about that timeline, objectives, and so on?
Well, so this is something that is really being developed, so I really don't have that much information about it yet, because in terms of timeline, the delivery, let's say for the Commission, is month 18 of the project, which is next year, June. And so it's really something that we haven't started discussing internally yet. I realize this is an objective that it's a little bit vague, and also it's very ambitious. So I don't think we're going to be developing a label for circularity or anything of that sort. It's more going to be based on some indicators. It's going to be a questionnaire, maybe to help companies get some recommendations or something like that. But I'm afraid I don't have a lot of details at this point yet.
All right, thank you. And the second question is, in addition to recycling projects, are you working on other types of circularity projects like eco-design, reuse of raw material, dead stocks, etc.?
Yes, so the 26 projects, I didn't get a chance to go much in detail because, well, for one thing, I didn't have enough time, but also they're being started up and developed now. But yes, we have 6 areas of innovation, so definitely eco-design is one of them. And the idea is to address different aspects of the value chain. The light went out, so I don't know how to turn it off. Anyway.
That's okay. But
so yes, the idea is to have, of course, I mean, 26 projects are a very far cry from representing the whole textile industry in Europe. So there's no chance for us to do everything or deal with every aspect. But we did try to get insight on different ways to achieve circularity. Yes.
Thank you, Jennifer. Well, I hope Maeva answered the questions. And well, as the project develops, we will be making sure that in another future webinar, such as today's, we are going to be inviting you back again to really give us an update.
Yes, thank you very much.
Other questions eventually to Jennifer before we move on to our second speaker? You are welcome to raise your hand. I do not see any virtual hands in the air, so I think again, thank you, Jennifer.
Yes, thank you so much for inviting me. It's been a pleasure to be here.
I'll
stay a few more minutes.
Yeah, of course. Thank you. And with that, we can move to our second speaker of today, who will be talking about the R-LIGHTBIOCOM project, new bio-based and sustainable raw materials, enabling circular value chains of high-performance, lightweight biocomposites. So I'm inviting David Fenollar from ITEX, this time from Spain, to come forward. Please share your screen and introduce the project to us.
Hi, good morning to everyone. I'm sharing my screen. That's okay now? It's in web?
Yes, we see it perfectly, the first slide.
Perfect. So, hi. Hello, good morning to everyone. Thank you first to ECOSYSTEX for allowing me to be here today. Now, my name is David and I am researcher at the ITEX Research and Innovation Center. Today, I will be introducing you to the main work carried out in the European project R-LIGHTBIOCOM. But first of all, let me explain a bit more about our Textile Research Center, ITEX. ITEX is a research and innovation center that focuses their activity on 3 key activities in the textile industry. Testing, characterization, and certification in one hand. At ITEX, we work closely with international standards to certify a wide range of textile products for many different companies. Additional to that, we conduct research and development activities in advanced textiles and as well as provide training to industry professionals. Specifically in the research and development department, we have over 100 researchers. Also, we collaborate with more than 150 technology partners to develop more than 250 projects ranging from comfort textiles, home and fashion textiles, to also high performance textiles for geotextiles, for aeronautics, ballistics. for composite application also. The majority of our work is conducted in our facilities, in which we have over 30 specialized laboratories. And we also have to our headquarters in Alcoy, here where I am today. It takes us 10 international offices that allow us to work with customers in more than 50 countries. But now we are discussing the R-LIGHTBIOCOM project. So R-LIGHTBIOCOM is focused on research and development of sustainable materials solutions for high performance and lightweight composites. With the consortium of R-LIGHTBIOCOM is constituted by 13 partners in different European countries, combining public institutes and university and private companies and research institutes. The main objective of the R-LIGHTBIOCOM is, as said in the slide, to obtain high-performance composites at low environmental impact. That means to minimize the ecological footprint of novel high-performance composites through their life cycle, including production, recycling, and use. This is coupled with enhanced mechanical performance, reduced weight, and novel functionalities. The application of these new materials will be for 3 use cases that we are seeing in this slide. In one hand, automotive for spoiler and trunk floor. Secondly, infrastructure for pollution profile for tunneling. And thirdly, in the aeronautic sector, for an inner panel of a wing. The methodology of the R-LIGHTBIOCOM project is, first of all, to develop a new bio-based resin formulation with improved recyclability and adapted to the needs of high-performance composites in terms of performance and processing technologies. Secondly, we redesign processing technologies for the obtention of lightweight structures, intermediates for high-performance composites with sustainable fibers and bioresins developed in the point 1. In the point 3, we develop new fast curing methods together with new non-autoclave processing techniques for the manufacture of the composites. In the point 4, we develop the recycling technologies for the resin and fiber components developed in the points before. And then we have an optimization framework for the composite modeling. In the point 6, we develop a life cycle assessment of the composites, of the high-performance composites, and then the validation of the R-LIGHTBIOCOM high-performance composites in the use case mentioned before. But now we are focusing on the point 2 that are regarding the sustainable textiles and for the bio-based resins. For the sustainable textiles, we are choosing sustainable fibers that are ranging from recycled carbon fibers to natural fibers, counting also with aramide, recycled aramide from ballistic and military applications, and then also basalt from the other applications. The ways of fiber valorization are, in one hand, with the short fiber selected. One way of valorization is carding manufacturing, as you see in the slide. This is a dry light technology that we have available in our facilities in ITEX, and we can produce non-wovens and slivers. This valorization technique allows us to valorize high fiber lengths. And as the difference that I laid and well laid, that we are able to valorize shorter fiber lengths, as you see in the slide. We are talking about carding. The first step in carding process is the fibers opening, blending, and sizing. All of this is taking place in a peak opener machine, and after that we blend the fibers. These fibers will be processed in our adapted carding machine. We are processing in our adapted carding machine for the obtention of, as we said before, non-wovens for resin fusion, thermoforming, or honeycombs, combining this last, the thermoforming and honeycombs with a thermoplastic, mixing the recycled carbon aramide and basalt with a thermoplastic, and then slivers for robbings, yarns, and textiles. This is the processing of recycled carbon fibers in our carding machine, blended with polyamide. The objective of the project is to obtain the maximum recycled carbon fiber proportions, and our objective is to reach 60% of recycled carbon fiber. Also, with aramide, we are ranging about 90% of aramide and 10% of polyamide for the processing, for the thermoforming processing. This, with the non-wovens produced by carding, we are taking that for infusion, thermoforming, and honeycomb processing. First with thermoforming, we work with different molds, and also with thermoforming compactation machine in ITEX. Also, the thermoforming, we can obtain honeycombs. We are working with a laminator that produce half honeycombs, and then we stick to half for the obtention of the honeycombs. With slivers produced by carding, we are able to produce robbings, yarns, and textiles. In the video, you can see the production of robbings that I show it in the photographs for pultrusion, or the manufacturing of the pulsed profiles for the infrastructure application. Also, we have producing yarns by ring spinning and open-end spinning, that these yarns, after we process that to apply the sizing, we are processing that into our weaving machine for the obtention of textiles from recycled carbon fiber, recycled aramide, and recycled basalt for composite, for high-performance composites. Or if you want to know more about the project, you have all the information here in the QR codes, and also you have the websites, you have the social network links, and also you have the main mails of the project managers. So thank you to all of you for your attention, and thank you also to ECOSYSTEX, Kamilla.
Thank you so much, David. I hope you can stay until the end, and then I would like to encourage everyone to ask any questions to you in the chat already now, which we'll then take up at the end when we have first in the Q&A. And now we will move on to our next speaker from the PROPLANET project. The presentation will be about towards PFAS-free coating for textiles, glass, and food packaging. So I invite Israel Bellanato Núñez from EDENE to come and take over the screen. Welcome.
Okay, I'll try to share my screen now. Okay, so can you all see my screen?
Yes, now perfectly in presentation mode.
Okay, thank you. So, well, I'll start. I'm Israel Bellanato from EDENE. I'm here on behalf of the coordinating and management team of the PROPLANET project. As support, I will have Oscar Calvo from ITEX, who is a specialist in textiles, answering the questions in the Q&A session later on. And we're going to talk a bit about PROPLANET, which is the project we're currently working on. The title of the project is towards PFAS-free coatings for textiles, glass, and food packaging. And first, let me introduce you to the concept. PFAS, which some of you may know, are poly and perfluoroalkyl substances. They are actually more than 4,700 substances that are used in almost all industrial sectors. That covers textiles, but also non-stick coatings for pans and pots, for example, food packaging, glass coatings. And the problem with them is that they take more than 1,000 years to degrade, and thus are heavily accumulated in the environment. PFAS have been detected in the blood of European and American citizens and in placental tissue, and they're associated with high cholesterol levels, weakened immune system, damaged organs, and cancer, ultimately. Okay, so the European Union has tried to define certain restrictions on the use of PFAS over time. In 2009, PFOS were included in the Stockholm Convention to eliminate their use, and for more than 10 years, they have been regulated under the European Union's persistent organic pollutants regulation. In 2020, PFOAs were banned under this regulation. In 2022, the Stockholm Convention included also salts and related compounds. And by 2023, it is expected that a global ban will arrive by the end of this year. So with all this in mind, the idea of PROPLANET is to address novel coating material solutions which tackle the problem with from a sustainable business perspective, enabling overcoming the barrier for environmental protection, safety, chemical improvement, and circular value chains. And so PROPLANET aims to substitute the existing PFAS-type coatings by designing and optimizing 3 different types of coatings, which would be hydrophobic, oleophobic, bio-based coatings, then non-stick and anti-corrosion protection bio-based hybrid coatings, and anti-soiling and anti-reflecting hybrid coatings. And the developed coatings find industrial applications in different sectors. For example, in textile sectors, we have technical textiles and textiles for home appliances. We also work in food packaging machinery, and we also work with low maintenance glass. As for the overview of the project, the PROPLANET project was granted 5 million euros for its execution. It's fully funded under Horizon Europe by the European Commission. The project will last 3 years. We started at the end of this year, 2023, at TRL 3, and we're expected to reach TRL 5 by 2026. And so the main idea of PROPLANET, as you can see in the graph, is the circularity by design and make everything safe and sustainable by design. Okay, so the idea is that we first define the properties, requirements, and the proof of concept for the project, taking into account what we want. So we want high functionality, we want no human hazard, low environmental impact, cost effectiveness, high recovery, and recyclability. Then we go on to perform chemical optimization, manufacture the coatings, and upscale them. After that, we can perform the validation in real environments, which involve the textile industry, as I previously said, food packaging, and low maintenance glass. And then we introduce a novel tool from the project, that is the PROPLANET replication tool. Okay, and in it, in silico toxicological models will be included, as well as environmental fate models, first principles based models, data-driven and multi-objective optimization algorithms. Okay, so that finishes the loop and can help define new properties, requirements, proof of concepts for some other new project or some other materials in theory, right? So that we can keep the loop going and we can progressively define better and better solutions. Also, PROPLANET will cover life cycle assessment, life cycle costs, and social life cycle assessment. We are currently trying to enhance the social acceptance of the new materials we are going to develop. We will define roadmaps to full standardization. We are currently also working on certification programs for the project itself. As for the objectives of the project, as I previously said, the main objective is to develop high-performance, safe and sustainable by design coatings to substitute PFAS, to reduce the environmental impact in the manufacturing process by at least 25%. We also want to take advantage of artificial intelligence, computing, and modeling to reach safe and sustainable by design solutions, as I said, with the PROPLANET tool. And we want also to boost high performance, safe and sustainable coatings in new markets. Okay. As for the impacts, well, the byproducts of the project should be, on one end, the set of multi-scale computational tools that I said previously with the PROPLANET tool, the new sustainable by design, safe and sustainable by design coatings, the development of safe and sustainable by design criteria and principles to be applied further in other projects, to enhance the social acceptance of these materials that could substitute very well PFAS, which are what we are going against, really. To develop certification program and to develop a standardization process and roadmap. As for the PROPLANET consortium, we are 13 different partners from 9 different countries, as you can see here. And the special thing we have here is that it is a very diverse consortium. We have everything ranging from universities to SMEs, research institutes, and also industrial end users. So we are covering the whole value chain that we are working on right now. As for the clustering of ProPlanet, we're in relation with all these projects, BioSushi, which deals with the sustainable surface protection by glass-like hybrid and biomaterial coatings, with Zero F, which covers the development of verified state and sustainable PFAS-free coatings for food packaging and upholstery textile applications, with Tornado, which covers new routes of safe and sustainable by design water and oil repellent bio-based coatings, and of course, Iris, which is also a member of ECOSYSTEX, as you all could see in a previous presentation today. And they are the international ecosystem for accelerating the transition to safe and sustainable by design materials, products, and processes. Now, let's try to delve a little bit more into the role of textiles in ProPlanet. So the first thing we want to do in ProPlanet is to synthesize cross-linked biopolymers, oil, wax, microcapsules in polysaccharide matrices. The ProPlanet team right now, or has already better say, performed hydrophobic functionalization of natural polysaccharides via esterification, etherification, and such, and developed a formulation of organic hydrophobic and oleophobic emulsions in bio-based matrices, prepared with alginate and ketosane bio-based polymers as encapsulating agents. On the right, you can see some experimental procedures carried out by our partners at ITEX, in which they test the water and oil repellency, the oleophobicity and the hydrophobicity of the coating applied at lab scale, of course, in a textile. Okay, then we should deal with the preparation and application of the final recipes we find of these biopolymers to the textiles. The formulated repellent coatings will be first characterized and manufactured, and then some textile auxiliaries and fabric preparation procedures, which will influence the novel bio-based repellents, will be set up. Then the repellents will be applied on the textiles, and the methods for applying the repellents, or the coatings, if you might, will be padding or deep coating and night coating as well, with different auxiliaries in each of these cases. And it is important to say that ProPlanet coatings look for alternatives not only to PFAS-based coatings for textiles, but also for partially bio-based water repellent compounds, which are already available in the market. And in addition to this, one has to consider that ProPlanet provides a solution for oleophobic bio-based coatings, which are currently not available in the market. So that is yet another reason why the ProPlanet project is competitive. Then we have to review or validate, right, the wear resistance and the repellence performance of the biopolymer in textiles. And this is done by testing the hydrophobicity and oleophobicity of the fabrics, and by testing the wear resistance with methods that are depicted in the pictures in the right. In the picture that is higher up, you can see wear resistant tests, or better said, the results. And on the bottom, you can see an image of a high hydrophobicity test. Okay. Then finally, we have the end of life of product and next use, which we have to deal with as well. It's important due to the circularity part of the project. So the chemical and thermal recycling of the cross-link biopolymers will be performed, and they will be reintroduced in the value chain for their reuse. And in our case, the coatings must respect the recycling process by introducing a debonding process, in which the coating, in fact, is going to be removed and possibly, and if all goes well, reused. And thus, a better recycling of the fabric should also end up being possible. Okay, so that was basically my presentation for the ProPlanet project. I hope you all enjoyed it, and Oscar and I will be ready for your questions later on in the Q&A section. Thank you, everyone.
Thank you so much for the presentation, Israel. And then indeed, if you have any questions, again, please type them in the chat, and then Israel and Oscar will be answering them at the end. And now that brings us to our last presentation of today. I would like to invite Annalisa Moro from Mogu to introduce us myfi, a scalable, regenerative, and competitive solution for the fashion industry with advanced myco-fibres. Annalisa, the floor is yours.
Hi, thank you, Kamilla. I hope that you can see now my presentation.
Not yet in presentation mode, just your screen. Yes,
no,
perfect.
Okay.
Perfect.
So as Kamilla said, we are project manager of the myfi project. I know that some of you already know the project, so I'll just quickly recap who we are. And but today I will focus on our updates, as we are already in the third year of the project. So myfi is a project that has been co-founded by the European Union under the Horizon 2020, and is a project that say reinventing a smart, circular, competitive textile industry with advanced microfibers. We start 3 years ago, and so we will finish next year. And we are really a big consortium, and we focus on the mycelium fiber. Our mission is to develop an innovative, functional, and high value, and of course, environmentally responsible bio-based textile. And we are focusing on a paradigm shift from basically a linear economy, where we are exploiting resources and we are focusing just on recycling, to circular economy, where really we are creating new material that can be regenerative and circular by design. myfi has 4 high-level goals. Of course, empower the textile industry to face the emerging challenges, meaning the scarcity of resources, meet the consumer demand, as today the consumer are demanding for new materials that are sustainable at environmental, but on not only level, and of course relieve the environmental pressures related to the textile industry, as you know, is one of the main polluting one, and of course engage the textile stakeholders and provide guidance to policymakers, so through the European Union. I know already we explained you a little bit our biofabrication, and today I want to focus on the upscaling. In particular, the upscaling on 3 dimensions, on the wet processing and finishing, and also on the application that we are already doing by prototyping. And I will just finish with some elements on our sustainability. Concerning the wet processing and finishing, basically after our biofabrication, we do some treatment to our raw material to create a material that has, of course, properties and advanced functionalities. We are trying to upscale our current process and go to a demo scale, and we are prototyping with our partners to reach material that can go on the market. So as I already told you, the process of scaling has 3 dimensions: the biofabrication upscaling, the upscaling of the wet processing and the finishing, and the application that we are doing. Just a reminder on what we are describing is a biofabrication process by design. This means that we regenerate feedstock that we select, and we go through a process where the mycelium grow and also and basically create a semi-finished product that's go through a process of finishing to reach our final products. What is really cool in this process is that it is regenerative by design, and that it applies circularity to a normal process of creating materials. We give a new life to feedstock, and we are taking account the end of life just in the design phase. And this is really important because it's a change in what has been done until now. Of course, we have some challenges. because we are doing a biological process, but we collaborate with mycelium basically. So it's really a new approach, but we are facing all the gaps that we have. Concerning the upscaling of the biofabrication process, we start at a lab scale, as many European projects, and with a dimension of our sheet and of our material produced that was quite small. And today we are pilot scale, where we are producing more material, and also the dimension of the sheet that we are producing is increased in comparison at the beginning of the process. But what is really nice and cool is that the next step, it will be a demo scale. So we will produce 20 times the quantity that we are producing now, and also we will produce 1 square meter for a week. So also in the dimension of the sheet that we are producing will increase. It's important to underline that we are going into the market at when we will finish our project. So this is very important. Another upscaling is the post-processing. We are collaborating with the tiny industry, and we are basically design a new way of managing our material, because in comparison to other materials such as leather, our material needs a more gentle process. So the mycelium, our raw material, goes into the wet processing, where basically the mycelium mats undergo a wet process where is gently washed. And of course, we also had dye and other substances to create it and to have a good quality. After it goes under a drying process, and the coating one, where we are using a natural coating and the BOPU coating to create the final material that after goes under the process of embossing and the prototyping. Here you can see our processing concerning the finishing. So we did many experiments on 2 types of post-processing. So we are using both wax and the BOPU. As you can see in the wax processing, we are using the bio-based content is higher in comparison to the BOPU. But also in the BOPU, the bio-based content is high, even if, of course, we are trying to increase this percentage. And you can see that also in the BOPU, there is a difference between the matte material and the shiny results, as the shiny has less bio-based content. Is weird, because the shiny one should have higher percentage, as we use resin that has a higher percentage of bio-based content. But these results can be probably explained by the density of the mycelium, and also probably on the spraying process that maybe it wasn't homogeneous. So the upscaling is until now is undergoing, of course, but is successful for main 4 elements. The fact that we are using technology that is compatible with existing industries. So we are just using technology that is not new at all, like from the scratch, but is something that is applied in other industries, such as the food industry, or also the vertical farming, but in another way. So we are looking at technology in a different way. We have partnership with the industry, in particular with tanneries, but also with the fashion industry, that we are supporting us to scale up and go to the market. Of course, we have a know-how that is patented, and we have 2 patents on the biofabrication method. And what is also important is that our process is adaptable and also regenerative, in the sense that our material can grow in different shapes and with different thicknesses, for example, and it can have also a different feature, and so this is very good. Also, if we consider that the fashion industry or other industries such as the automotive have high requirements to the access. I will focus on that I think is very nice to see on our application. So on the prototyping that we are doing nowadays. So we are applying our technology to the real world. We are going through various steps. First of all, the characterization of the material, as of course we want to have a high standard, and we want also to have a standardization of our materials, so to have quality that is standardized. And we are prototyping in two main industries, such as the textile industry, the fashion industry, and the automotive industry. After the prototyping, we are also testing and analyzing our environmental performance. Today, I will just focus on the fashion industry as we have some prototypes to show you, while for the automotive industry, you will wait because we will have some prototypes in the next month. So first of all, we tried and we prototyped different works finishing. Here you can see many, some bonded with printed cotton and snap button application, other cover stitching, black thermal welding. So we are using many technologies to also see how our material reacts in different conditions and with different works finishing. Other prototypes, you can see that here, for example, we have a metal zip. So it is used as a normal, we say, fabric. While in the right side, you can see the material under, for example, the digital printing. So we are using also different technology, and I would say more actual. Here you can see some prototypes of card holder with, for example, manual weaving, or for example, with high frequency technology, and also with different colors. And here's some of the last prototype, for example, card holder with laser cut, and you have on the top on the textile that is printed with the digital printing, and in the right side a pocket that we made. As I say, we are also considering sustainability. Our method is regenerative by design, but we should, of course, analyze both the sustainability at an environmental side and the LCC, so an economic side. Just to remind you that we are using manufacturing by design. This is very important because we are shifting our paradigm from a linear economy to a circular economy. So the design has a key role, has the 80% of the product's impact is due to design phase. So we are really collaborating with nature since the beginning. And this helps us to apply the future to the present design, because we are taking already in the design phase into account future regulation, for example, a trend such as the EPR. So we are trying to create a material that is compliant with the future rules. We done a life cycle assessment on our pilot scale and on the biofabrication process. All of you knows what is the life cycle assessment. That is a methodology for assessing environmental impacts, and we are trying it to our biofabrication. It's important to underline that life cycle assessment is a tool, but it's just a point of starting point. It is not a point of arrival, and it's important to think in a life cycle of thinking. So really to focus on the improvement. So for us, it has been important to do that, to really understand how we are acting and how we can improve since the beginning our material. We also test the biodegradability and the compostability of our material, and the tests are very good. Of course, the different treatments may jeopardize our biodegradation, but we are testing and investigating the more how we can improve that and the impact of each treatment. But it's quite impressive that I mean, we have high range of biodegradability here. These are our preliminary results of the life cycle assessment. You can see that we have, of course, some impact, but the impacts are also on some aspect that we can solve in a easily way, also in the demo scale. For example, on the raw material, we are trying to source as locally as we can, and also the thermal energy. For example, we are trying to insulate our pilot scale, and of course the demo scale that we will do to make it more efficient, so to reduce this. But for example, we don't have much impact on the water, for example, that is a scarce resource. So this is quite impressive if you compare it to other type of material that you use in the fashion industry. Just to finish, today we are working on the prototype, as I say to you, just not only in the fashion industry, but also in the automotive industry. We are upscaling to reach the demo scale, so to make it in a bigger scale. And we are really focusing on the creation of a new material category, as our material is very new and innovative. So we don't have other similar material. Just some takeaways, and I will finish. So the upscaling that we are doing is really real, and the prototypes are demonstrating the feasibility of spreading mycelium-based material into different sectors. LCA evidence are supporting our innovation. And of course, I think that we need more investment in the design of new material to accelerate the shift towards circular economy. And yeah, so thank you. And I stay at your disposal for any question.
Perfect. Thank you so much, Annalisa. And with that, we arrived to the Q&A of the webinar. However, I do not see any pending questions so far in the chat. I see that someone wants to get in touch with Israel, so I think you can do it. However, there is a question at the end for Israel, so maybe if you can jump back with your camera on, or joined by Oscar as well. So Paula Francavilla here says in the comments that they are working on some novel applications for their fabrics. Is expected from your side to use that type of coating with any kind of textile surfaces?
I think Oscar, if you might, if you might.
Yeah, for sure, Israel.
Okay.
So hello, everybody. Thank you to the ECOSYSTEX platform for the participation in this webinar, and thank you also for PROPLANET for involving us in the project. Well, for the moment, we are expecting to apply this kind of coatings on cotton and polyester and their blends, because are the most usual fabrics and textile materials, even for the material that is expected for the project. We want to start with the most common materials, but of course, for further industrialization purposes and to increase the TRL up to the commercially available level, we cannot forget that the main restrictions regarding the use of PFAS on textiles will affect, for example, technical workwear, and this kind of technical fiber that are used to manufacture protective clothing and so on. So imagine for aramide types and some blends of flame resistant fibers. So for sure, the optimal case would be the application of this kind of PFAS-free coatings on the most wide range on textile materials as possible. But in the frame of the project, cotton and polyester and blends will be the focus of our main work.
What I would like to add is that if I just wanted Oscar to give a proper, more developed explanation that I can do. But if you want, Paola, you can actually contact both me and Johannes Seif, which is the actual coordinator of the project. He's currently not available, but I think I left his email in the slides. I don't know if the slides will be shared with you all, but I can leave my email as well in the meeting chat. So I'll leave it now, okay? And if there's any need to contact us, it's perfectly fine.
Perfect. Thank you so much to both of you, Oscar and Israel. I hope, Paola, that answered your question. I can see in the chat that you say yes. Any other questions that anyone would like to bring up now? Still, we have some time left. David had to leave, unfortunately, but Annalisa is still with us. The last presentation, if there are any questions there, then we can take it now. Also, you can raise your hand and ask directly. No need to type it in the chat anymore. Okay, if that's not the case, then I will thank very much to our speakers for the great presentations, and I will take 2-3 more minutes of your time just to wrap up quickly, and then we're going to be able to finish a little bit early today. I hope my screen is well up now. So just a quick overview of the upcoming activities and events. Well, as the beginning, I mentioned the ECOSYSTEX conference. So once again, all the information is in the chat. If you would like to consider joining, then please do so today and latest by Monday. After that, in November, and then later in February next year, we are going to organize further episodes of the Insights series. So we are going to publish the upcoming agendas, the registration links. It always works the same way. You just have to register via the form, and you are more than welcome to join us here online. We are also recording these webinars, so it will be published online, and we are also going to share the presentations with you. Besides events that we organize ourselves, our member projects are also organizing and participating at some conferences. So here an insight to that. Still in September, online, the S4 Fashion project will present at the Wanda conference. The presentation will be about how to build ecosystem intelligence to reshape an industry. There is a registration link that's available. Tila will drop it in the chat if you're interested. And the other event that's coming up is on the SUSTRAC project side, the Inspire conference, which will take place also online in November. More details will follow on their website, so you're more than welcome to follow the website, and that brings me to my very last slide. Follow ECOSYSTEX on LinkedIn. This is a page where we are not only sharing ECOSYSTEX content and updates, for example, the invitation and the agenda to these webinars that we have here today, but also we are trying to collect and share all the content, all the upcoming events, information about and organized by our member projects too. So if you want one source of information to collect all the knowledge about this field Europe-wide, then please follow us on LinkedIn. And finally, if you are part of a European funded project that is not yet in ECOSYSTEX, but you think would be a good fit for this network, then you're more than welcome to send us an email with a brief description of your project, and we are going to take it from there and hopefully welcome you as well in the network. with that, I thank you very much for being with us today, and I'm giving you back quickly looking at how much time, 10 minutes of your time today. In some countries, it's still lunchtime, so bon appétit, have a nice afternoon and a nice weekend, everyone. And hopefully see you in either Barcelona or back here in November. Have a good day. Goodbye.
Thank you. Bye.
Bye.
Bye. Have a nice day.